Welcome. Thanks for joining us. This is Nick Bubitz with Veriphase. Today we'll look at the last module of the ADT Pro Workflow Enhancement Suite, which is DataViewer. DataViewer is really a unique tool designed to allow for easier communication and portability of data. Typically data files for phased array can be very large, from several megabytes to even gigabytes on some systems. And especially when you're in remote areas on slower connections, it can be really hard to send an entire file for review if you want to communicate what you're seeing, or if you just need to upload the data, talk to somebody. And of course, the user, on the other hand, also must have a whatever license to review that data as well. In addition, phased array data can also be difficult to understand for those not trained in interpretation of the data. So sometimes you really want to manipulate that data in a way so it can be understood easier by the other user, which might be the guy that needs to make the repair, might be your client that needs to look at it and understand it. So with all these kind of things in mind, we thought the DataViewer was an important tool to add to the ADT environment, and it's really just a foundation at this point, and we plan on doing a lot more with it, but it's already pretty remarkable in what it can do. So for today's short video, we'll be using the four-group weld I think we've used in past videos. We can see here, typically if you want to communicate your data to somebody that isn't next to you, you can use send screenshots which lack the ability to manipulate them. You can send the complete data file. You got to wait on your side to upload it. They've got to download it depending on connection speeds, etc. That can be tedious. And then of course, if unless you have some kind of free viewer, you both must have a license or a hash key in order to view that data. So that's another rehash of some of the issues. But we can see the four-group weld on the right there. The other big problem is the file size. So looking at this weld is a pretty basic 1mm scan, 1 degree scan resolution file, but 4 groups, a little bit thicker, 1 inch. So a couple index points, about 21 megabytes, and then the DataViewer file there at 192 kilobytes, just to give you an idea of how much data reduction there is. And at this point, we're not retaining everything, but we're retaining a lot of the important information that we can still view and communicate things about that file. So that's some of the aspects we'll want to dig into. When I started in the industry, phased array was not yet accepted by the codes, and there was a big enamor for radiography, because when you showed it to a client, it obviously looked like the weld. And I think we still lose some of that with phased array. On a lot of the instruments, you see the flip display, and people don't understand why their single V all of a sudden looks like a double V. And we start taking screenshots out and trying to explain to a client what's this big red blob and this and that. So just some things to keep in mind as we get into it. We're not going to talk about it too much. We're going to get right into the viewer and kind of expand upon it. So with that in mind, we'll go ahead and open the ADT program, and we'll just talk about these things as we go. So again, we've covered most of these already. We touched on the DataViewer in the last video about report updater, because they kind of tie hand in hand. Often you'll do this at the end when you've already analyzed the data, you've cut out those indications you haven't found relevant, and you want to do a final reporting or communication. But we decided to do a separate video for it. The unique thing about DataViewer is it can be run much like the reports. A DataViewer file could be run during the single weld process, the multi-weld process, and we've omitted those during the videos, but anytime I've done the processing in those, we could have been creating the DataViewer file at the same time along with a report. And when we did the report updater, we could have been creating a DataViewer file, and then we can also create it here by itself. So in this case, when we want to do it and the final analysis step, we've already done a single weld processing or multi-weld processing, got the ADT file. Operators went through, he decided, okay, I'm going to cut these ones out, I'm going to make changes to these indications, I'm going to resave that ADT file. Now I want to do my final report, or I want to get a final DataViewer report. So I've saved that in its own little folder. Here we go. So this one's been updated by the operator after the ADT results. When we go into the report updater module, we've already covered the report, but we can also do the DataViewer we see, and the same setup we've seen everywhere. super easy. We're going to extract all the information about the weld and the parts, so you don't need to do that. We talked about this during the report, the difference between the cloud, peak, and volume. Again, the cloud is more like you see on the instrument, or the actual data representation, the peak being the highest amplitude spot, and the volume being the entire volume of the flaw, more for, do a repair or communicating the effect of the flaw. And good thing about the data viewer portion of this is we don't have to make that selection. The report is going to be an image, so you have to make that ahead of time. Here we can choose any one of these, and we're going to be able to manipulate that within the data viewer. So we'll look at that specifically when we get to the data viewer file. So this typically runs very quick because it just needs little pieces of the information about the data. And like that, we have the data viewer here, which I'll make full screen. And it has opened in the, looks like, peak amplitude and the weld volume. So before we get really into the total use of the tool, just some things to point out. I talked about on an OmniScan MX, MX2, without file merging, if we have a single V like this weld, we do these data skips that show the different legs. So there's the first leg, second leg. It's just a repeat of the weld in order to view those throughout the skips. Well, when you send that into a client, it can be very hard to communicate what the total effect on the weld is, and obviously bringing it into an analysis program and doing merging is the answer for analysis. But when you want to communicate that, maybe all you have is OmniPC that can't do that, or you can't, you don't want to do it by hand on your reports. We've built in, going from that S-scan here to the weld, which is going to do the full volumetric merge and put all of the indications across all 4 groups in this case into a single volume representation of the weld. So just right there, just a much easier picturesque representation of the data for people to view. We talked about the cloud, peak, and volume. So if you're talking to somebody that wants to be able to look at the data like you're seeing it, we can go to the cloud. It can look very much like the instrument. Here we've selected a S-scan and a C-scan, and we have the just like it would look on the instrument with the right colors, and then we have a color amplitude based and volumetrically sized indication. So right away, just looking at the C-scan, I can tell number 3, number 12 are very high amplitude, 1 and 2 are very small, and these are very wide and longer indications throughout here. So we get a lot of good information just from that little piece of information. But we want to tidy it up for the report. I can still tell these are probably slag or porosity. These might be surface connected. These might be root conditions. These might be lack of fusions. You can still gain quite a bit of information just looking at the highest peak. And then maybe you're going to go straight to the guy that needs to make the repair, and it makes more sense to talk about the total area that needs to be cut out, or the total effect on the weld. You can kind of see how these things overlap, and I like the volume for that. You can kind of see the total effect where these 3 lack of fusions are really in line, and their effect on the total area. We'll go back to cloud now that I've shown that. So we have interaction with the indication table. So this is the same indication table after I've went through it, saved it in the file. This is going to look exactly like your final report, and it's going to be the same that's in the final ADT file that you save. So completely interactive. As I click on these, you'll see a highlight in the C-scan, and you'll also see the actual beam path that was taken to hit the flaw. So if you're talking to maybe your level 3 and you're back with the actual file, it might help in the interpretation knowing how that flaw was seen. So that's a very useful feature. Just going to turn that off for a second so it doesn't busy us up. Talk about a few more things first. And then we have the merge view, which is going to show all the defects. And I can break that down by group very easily. I kind of isolate the area, kind of declutter it. We can all focus on a certain area and go. And then all these are interactive as well. So if I start clicking on them in the C-scan, etc., it's going to go to them. The grayed out ones here are not in the channel I'm in, so I can either go to merged, or I can go to whatever channel they're in, and they're going to be active. And then we also have the scan check or the quality type things built in here a little bit as well. So with just one glance, the person viewing this file could tell that I didn't have any data dropout issues and no loss of coupling issues, either by looking at the green lights here or here. It doesn't have the intimate detail in there right now, but it is there. We hit the little information button up here. We actually can have a little bit of the kind of report of how it was run, so you don't have to communicate that. They can kind of see your advanced settings, what height and length sizing you were using, whether or not you had the loss of coupling, etc. So what version you're running, some basic info there, which is very helpful. And then the C-scan down here is actually pretty interesting. We do have a zoom feature that we can use to go in a little bit tighter. And then one of the neat things, if I go to the small screen, just because I think we're getting cut off a little bit there. So we have some range and slice features. So we can actually have these pop up as they appear in the scan. So if you want to move down the weld and communicate and talk about them, or have them appear as they would, we can do it that way. We can actually isolate a certain volume. So if we want to set this to a certain value, we have some numbers going on there. Then we can lock that in, kind of like locking the cursors on the analysis feature, and look at an inch or 2 inches or whatever at a time, however you want to review it that way. Go ahead and unlock that. Or just the slice, where you're just doing that one little itty bitty slice as well. It's possible there. Kind of a neat little feature. The ability to kind of play that like a movie, control the speeds. You just kind of sit back and see the flaws roll in as they appeared. Stop that. Go back to that indication list just a little bit more. So again, we have all of our full information here. And really, if I want to review these, I can click on one. And we have all of our information that was in the indication table as well. So we kind of have the basic info up here to kind of see how real and relevant it is, both the ADT score, the confidence factor, as well as the amplitude, which is kind of the baseline for a lot of indications on whether or not they're acceptable. But then if you go down here, you do get all that kind of micro information, whether it's ID connected, start and stop, length, height, reference number, that kind of thing. And that's really just a really quick look at the data viewers. So again, breaking that 21 megabytes down to 190 some kilobytes, incorporating the data quality type factors directly into this file as well. Something I can upload and download very quickly. I can see the beam paths. I can view the data in a merge fashion, and then the detection fashion, as well as kind of manipulate the data and talk about it and maneuver through it. Thanks again for joining us.